Hello everyone, my name's Scott and welcome to this practical tutorial on transistors, part of our basic electronics series. The transistor is, you can think of the transistor basically as an electronic switch where very little voltage or current is applied to the switch to turn on a lot of voltage and current. And depending on the PNP is how much voltage and current you can pump through it. But we'll get into that in a minute. First off, I think you need to know what a transistor looks like, both for its schematic symbol and physically. Physically, what it looks like is it's round on that end, and it's flat on this end, and you should keep the flat end facing you. So this is, we have NPNs and PNPs. First we're going to discuss NPNs. NPN. Okay. Now this is our transistor and it has 3 legs. And those 3 legs are the emitter, the base, and the collector. When it's facing you with the round end facing away, you have the emitter, and it's important to get these right, and you'll see why. The emitter, the base, and the collector. And, you know, everybody comes up with these snazzy little acronyms to remember this. If you want one, I'll give you one. Enjoy baked cookies. How's that? Enjoy baked cookies. So from left to right, you enjoy baked cookies. And so that's what the NPN looks like physically. And now schematically, what it looks like is this. We have our circle. And this line goes down here, over this way, down, over this way, and then down again. This comes out here. And we have our collector, our base, our emitter. And here is a little arrow. And the little arrow is always on the side of the emitter. So when you look at this in a schematic, you're not going to see the CBE. What you're going to see is you're going to see this little schematic here. And that's going to be, and depending on where the arrow is whether it's an NPN or a PNP. Okay, so we have our electronic switch here. This is the switching part. This is the part that turns on and off the switch. It takes very little current and voltage to turn on the switch. And then we have our current or voltage that passes through here. So this is to the positive. This is to the negative. And you'll see in our schematic how current flows here. So that's our PNP. That's our electronic switch. And you'll see it in a circuit. As a matter of fact, let's see if we can draw a circuit for it right now. Okay, so we have plus volts. And you should remember from our earlier lesson that this is a diode. And you should know that a diode, or this particular diode, allows electricity to flow in one direction only to protect your circuits from polarity issues. Okay, we have this here, this here. This, of course, is a switch, a manual switch that we push, and not a digital switch. Or, I'm sorry, not a digital switch, electronic switch. It is digital. It's either on or off. But and this here is going to be an electrolytic capacitor, which you also know from an earlier and then this runs to ground. Now you may be asking yourself, well, where is the Where's the transistor? Well, we're about to do that in a minute. Okay, so coming off of the plus power, we go to our transistor. So now let's build our transistor. And even though you won't see them in most of them, and this is just a little mistake, and we've got a resistor here, and we'll label what these are in a minute. And then we've got this that looks like a diode, and it actually is a diode, but it's a diode of a different type. It's a light emitting diode. Okay, now this goes down here, over, down, over, down. We've got our little arrow, because that's where the emitter is. This is plus volts, this is ground, as we've learned from an earlier lesson. Now we come off of here with another resistor to our base. Okay, so basically what you're looking at here is this is plus volts. I know it looks like a 1. So this is our little circuit using our NPN. Now the NPN, like I said before, is a switch. So when you apply power here, it allows power to flow through here. So right now, according to the schematic, if everything's hooked up to the proper voltage, you don't see this LED is off. It's actually going to ground. But there's no current flowing through here. So this LED is off. Let me give you some ranges for these resistors we're using. We're going to use a 22K ohms here. 22K. The capacitor could be anything, 10 UF, 100 UF, 1 UF. It depends on how long you want that light on for. Now, in one of our earlier lessons, when we had the capacitor and we used it to keep the LED on for a longer period, it was actually a very short period that was on because it drained. The capacitor was actually powering the LED. So it drained the capacitor to power the LED. In this instance, it takes very little voltage to keep the switch on, and the capacitor is not powering the LED. Well, theoretically, I'll explain that a little more in a minute. But the capacitor is not powering the LED, but just turning on the voltage to the switch. So it needs very little voltage, which is why we have a 22K resistor. And a common resistor for an LED is a 470 if we're using 9 volts. So let's assume it's 9 volts. 9 volts. Okay, so we'll use 470 ohms resistor here. And we'll just call this capacitor 10 UF. 10 microfarads. Now it's electrolytic capacitor. As you can tell, it's, by this curve here, we went through capacitors. It's electrolytic capacitor, and so you have to place it in properly, otherwise you will blow it up. It will explode if it's given enough juice. So this is the positive side, this is the side to ground. And you can go back to our capacitor lesson to see what they look like and how to know which is which. But this is an electrolytic capacitor, and it's 10 UF. So this is our circuit now. So now we have our circuit designed. We have our little switch, and this guy here, like we're showing here in the schematic, this is the collector, this is the base, and this is the emitter. So when we breadboard this circuit, as you'll see, because we're actually going to breadboard this for you, I don't know if it's going to be within the 10-minute YouTube video limit. We might have to make a second video of the breadboard. We also have to go through PNPs. So the way to think of think of this as a little digital switch. When we physically put our thumb on this switch here and press this down, we then supply juice to the electrolytic capacitor. It fills up the electrolytic capacitor and it pushes against this switch. When that pushes against that switch, current now flows down through this resistor, through the LED to ground. And I should have did a little line before ground, but that's okay. And then that lights up. When we let go of the switch, the capacitor still has juice. So what happens is it pushes against this switch still. So it keeps this light on. It keeps it a lot longer than if it was powering the LED itself, because it's just being used here. Now, you may ask, where is this current going? You know, it's pushing against here. If it didn't flow somewhere, then it would never drain down. Well, in the NPN, the current actually flows down through here, so there's a way for it to go. And you'll see in the PNP version of this circuit, when we draw out that, you're actually going to see another resistor here that goes to ground, so that can slowly drain, because in the PNP it doesn't drain through the transistor, but in the NPN it does drain through the transistor. Since we're up and running and we're open, let's do a PNP. P and P. Now, the funny thing about the PNP is it's pretty much identical to the NPN. I didn't even have to draw this a second time, actually, and I probably should have saved myself the embarrassment of doing so. But once again, we have E, B, C. So this is the PNP. But the schematic is actually quite different. It's actually the opposite of this. So let's draw our schematic symbol for the PNP, and hopefully over time doing these videos I'll get better at drawing this stuff. Come down, over, down, over, down. And so we still have this as our base. This is still B for base. But the emitter and the collector have changed places. So this is E up here. And then this is C down here. So remember, the arrow is always on the side of the emitter. So the way you tell that in the schematic is you see the arrow is on the side of the emitter. So I know, because of the way this is done, that this is a PNP. Well, what does a PNP do? An NPN, as you know, when we apply power to the base, it turns on the switch. Well, a PNP, if there's no power here, this switch is on. So think of this as a push button normally open, and this is a push button normally closed. What do I mean by that? This is a push button normally open. If you're not pushing against it, then the circuit is opened. So if you push against it, then the circuit is closed. Well, the opposite of that is if I push, it opens the circuit, and if I let go, it closes the circuit. So that's what this does. So it's two different types of switches. So if there's no current here, this is on. There's flow here. If I put current on here, it actually flips the switch and stops it. Now, the thing to remember, though, when you're placing this in your circuit is, see, you can't think of E as negative and C as positive, because in a PNP it's the opposite. For polarity, there's your plus, and whoops, I connected it to that, shouldn't have done that. And here's your minus. Actually, I'll do the ground symbol. That way, you know what ground is minus. If you looked at one of our earlier lessons, you would have saw all the different symbols for positive and negative that you can that I've run into anyways. Okay, so now this is our PNP, and of course we have a circuit for the PNP as well. But the funny thing about this circuit is me just erase some of this. Unfortunately, my eraser tool, I gotta find a better one, because unfortunately my eraser tool doesn't erase, to give me a choice of color to erase in the background. So let's erase this, and we'll fill this in. Okay. And let's go back to our background color, fill it in. Okay. Go back to our pen, and it's the same thing. Down, over, down, except now, connected here, this is still the base. This is the emitter instead of the collector. So we've got our arrow is up here, and this is our collector. And once again, this is our base. The base is the same. Okay, but we need to add something else to this circuit. Now, what we'll do is we'll add a line here, because this will all be connected on the breadboard. So we add a line that comes over here, and then we have another resistor that comes down to here. And that goes to ground. And this resistor, I don't know, it depends on how quickly or how slowly you want this to drain. We could make it another 22K. We could make it 100K. We could make it 470 ohms. It'll drain quick. Let's make it another. Let's make it 100K. Sorry, 100K resistor. It'll drain slower, but we'll make it 100K. 100K. Sorry about that. I know that things are getting tight here. So that's 100K. Yeah, let's do a better job of that. Let me choose a thinner pen size. That'll probably help. And here we go again. This is 100K ohms resistor. Okay, so let's see. What happens with this circuit when we turn it on? Well, actually, right now, if that's plus volts, this light is on. There is nothing shutting it off. So this LED right here is actually on right now. Now remember, with the NPN circuit, we had to push the button on to get voltage to turn on the light. Well, right now this voltage is on. When we add voltage pressure, it's going to shut off the LED. So it's going to do the exact opposite. And that's what's great about the NPN or the PNP. You've got opposite results. So no matter what you're trying to do in the switch, if you want to turn it on or off, depending on whether there's voltage or not, you just choose an NPN or a PNP. Okay, now how do I remember which one is which? An NPN I think of as no power, no power. So if there's no power going to the base, then there's no power flowing through. And with the PNP, I think if there's power, then there's no power. When we push this button here, this capacitor fills. And this provides pressure against here, against the switch. Now this is a electronic switch. There's no mechanical parts in here. So what happens is, now the capacitor fills up. It puts electric voltage voltage pressure against this switch, and then turns this off. And when we let go of the switch, what happens is, because this pressure here, and this light is off, it doesn't drain through here. If it wasn't for this resistor, if we didn't put this resistor in here, this would stay off. I won't say forever, because there is some bleed, but it would pretty much stay off for a very, 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 very long time. You couldn't use it as a predictable element in your circuit. So we have this resistor here. Now what happens is, it's providing pressure here, and like I said, in the PNP it doesn't drain through here. But it's slowly draining here to ground, and slowly alleviating the pressure, so that once this capacitor has been drained, now this switches, once the capacitor has been drained, the switch loses its pressure and the light comes on. So it's the opposite of the PNP. And I hope I explained that properly. If not, you guys will let me know, and I'll go into more detail in a future video. But anyways, there's two circuits. You can go back to get the circuit for the, actually let me write that down here. This was for the PNP. PNP. Okay, so this is for the PNP. The other circuit earlier was for the NPN. This is a push button here. I don't know if I've done that in an earlier video, but this is a schematic symbol for a push button. And you'll see that when I show you the two when I show you the two lab results. We'll actually breadboard both of these circuits. And that should just about do it for this lesson on transistors.